Hi guys, welcome back to my channel, and in this video I will teach you how to excite this car alternator with the help of this capacitor bank. Okay, so I'm using 3 capacitors identical, and each of them is rated at 110,000 microfarads at 15 volts. Also guys, to run this alternator at high RPM, I will be using this washing machine motor and connect the 2 pulleys with the help of belt and pulley system. Now guys, the plan is to mount this belt on the pulley of this motor and that alternator, but somehow this belt is not fitting the pulley of this washing machine motor. The gaps are very small and the gaps for the belt are very large. So I will have to remove this pulley and replace it with another one that fits this belt. Okay, so let's start with it. Okay, so guys, there's a little change that I did to the setup. I have removed the washing machine motor and replaced it with this 1.5 HP permanent magnet DC motor, 4000 RPM, because it has a much higher torque than a washing machine motor. You can see that the voltage is 180 volts and you can see here that I mounted the belt to the pulley, which is connected here to the alternator. And guys, this entire setup is placed on a plastic insulated heavy duty metal base. Okay, so guys, these four white wires that you see, this one, this one, this one, and one is here. These are coming out from the star connected armature winding of this alternator. Now the armature winding is responsible for generating the current that is induced when the rotor or the field winding rotates inside this alternator. Okay, so what I have done is I have connected the four armature wires, star connected armature wires, to this bridge rectifier, three-phase bridge rectifier, and the DC output appears as positive over here and on this pin, okay, and negative appears on this entire body of the alternator. Now this red and blue wire, these are the wires connected to the brushes that in turn are feeding the field winding of this alternator. Okay, and field winding is the rotor which is responsible for inducing magnetic field in the armature windings, which in turn produces current. And final extraction of electricity will be done from this positive or this positive terminal and this negative as the body of the alternator. Okay, so guys, now comes the connection part. Now guys, this part is very important because everything is very specific. We cannot change anything over here. Okay, so first of all I will show you that this long screw and this this point both of them are positive. Okay, so let's do that. Okay, so moving the pointer towards the continuity checking mode, okay, to this point. Yeah, so now when I will connect these two terminals, it should start beeping. You might hear it. Yeah, and it shows 1, which means 0 resistance almost. Yeah, now if these two terminals are directly connected, that means the resistance is almost 0 and it's a short circuit, and then this multimeter will start beeping, and here 1 or 2 will appear indicating minimum resistance. So as you can see that this point and this point are positive. So what I will do here is I will open this nut, okay, place this wire over here. Red means positive of the brush connecting the field winding or the rotor winding. Now I will connect here another wire and then place the bolt back. It is connected. So this wire is now the common positive of this entire alternator. Now comes the negative. Now for the negative I can connect this wire to this point. Okay, so it is not necessary that I connect the negative over here. I can also connect it over here or here, but this wire is not long enough, so I'm going to connect it over here only. Now I believe that this screw is also very thick. I don't think that it is going to pass through it. Yeah, it is not passing through that. So I will use another wire. I will connect it like this and place it on the side. Okay, so now the common negative of this alternator is this black wire, and this white wire is the common positive of this alternator, meaning the negative of the armature winding and the negative of the field winding are connected at this point, and the positive of the field winding and the positive of the armature winding are connected over this point. Now comes the part where I will connect the capacitor bank. Okay, so guys, this white wire, as I told you, is the positive, and the positive of the capacitor bank is this wire. Okay, so I will connect this wire to the white wire, meaning connecting the overall positive of the alternator to the positive terminal of the capacitor bank. So guys, the positive terminal has been connected. Now for this process to work, it is really important that the capacitor bank is already charged and the system is in the running state. And when it is in the running state and the capacitor bank is already charged, then all you have to do is simply connect this wire of the alternator negative to the negative of the capacitor bank, and this alternator will start generating electricity. Okay, so let's do that. Okay, so for charging the capacitor bank, you can use any power source. Like here I will be using this 12 volts 7H UPS battery. Okay, so red is the positive, connecting the positive to the positive. Okay, yeah, the capacitor bank is charged now. Let's disconnect it. Now we don't need the battery anymore. Okay, so guys, now comes the part where I connect this large DC motor to the power supply and start it. Okay, so here I have 60 volts DC coming, 50 to 60 volts DC coming from an e-bike charger. Okay, yeah, you can see here 54 volts, around 54 volts. So that voltage is going to run this large motor. Okay, so let's do that. Yeah, actually the power supply is not enough to start this motor. Since it is connected to the alternator, there are few frictional losses, so I think I will have to increase the power supply. Okay, so guys, initially the power supply was 100 watts. Now I've increased it to 2000 watts. Okay, so let's turn it on now. Yeah, actually the mechanism is vibrating a lot for some reason. Now that's bad news, because now I will have to figure something else to rotate this alternator. Okay, so guys, finally, as you can see here, I am giving a 24 volts 2 amperes power supply from this SMPS adapter and 12 volts 2 amperes from this adapter, and together both of them are connected in series to this DC motor. Now this DC motor is a 110 volts DC motor, but at present I am operating it at very low voltage, which is 24 plus 12, that is going to be 36 volts. And this is the pulley system that I have made with two back-to-back connected drill chucks with the pulley in between. Now the alignment is not perfect, but still it does the job. So guys, the two adapters are connecting over here, and as soon as I will turn on these two switches, the adapters will start providing power to the DC motor. But before I do that, I will have to hold the DC motor, because it is going to start running at a really high speed and it will get all shaky. Okay, so guys, I'm turning on the supply now. Look at the DC motor. Okay, go. Yeah, the system has started and it is really shaky. Now I have to touch the terminal of the capacitor to the alternator. You can see guys that initially it was freely running, so it was really shaky, but as soon as I connected the charged capacitor bank, the alternator jumped to the excitation mode and it slowed down the motor. Now at present the alternator is generating electricity, and also it is charging and discharging this capacitor bank. Now let's connect some load to it. These are the positive and negative terminals to which I am going to connect the load. But before I do that, let's measure the voltage that is being generated over here. Since the RPM, as we can see, is not very high, I'm not expecting much at present. Yeah, it is only 3.47, 3.2. The voltage is very less. Yeah, it's around 3.5 volts. At higher RPM, the alternator will generate 12 volts of course, but since as you can see that the motor is much smaller than the alternator itself, so it is a bit difficult for the motor to handle this kind of load. So anyways, let's connect some load to it and see if it can light up this car headlamp. Yeah, as you can see that it is lighting up. Also it is very bright over here, so it is difficult to identify that. Okay, so guys, after a lot of alignment issues, finally this system works pretty good. I'm using two 24 volts adapters connected in parallel and it's 2.5 amps, and this one is 2 amps, making it 4.5 amperes at 24 volts. And this laptop charger is at 20 volts with a current rating of 3.25 amperes. So these two are connected in parallel, and this one is connected in series with these two. So 24 plus 20, it's 44 volts that I am feeding this 180 volts motor. Okay, and this pulley is working great, and it is completely aligned. There is just a minor difference, but it is working good. Okay, so guys, turning on the switches. Yeah, you can see that the motor has started and it is running the alternator. And now, oops, the wire came out. Yeah, okay, so guys, you can see that the high speed has picked up. Now all I have to do is connect the negative terminal of this alternator to this capacitor bank, negative terminal, and then this alternator will get into the excitation mode and this entire system will slow down. Okay, so let's do that. You can see that the system has slowed down now, because now the alternator has entered the excitation mode. Yeah, the front view is like this. This pulley is a little bit shaky, but not that much. Yeah, now it's time to connect some load to it and also measure the voltage generated by the alternator. Yeah, okay, so guys, now you can see that the alternator is generating more than 6 volts, almost 6.5 volts I would say. So that is a lot more improvement than the previous value, which was only 3.5 volts. Okay, now let's connect some load to it. And one more thing guys, we don't need the capacitor bank now. We can remove it, and still the alternator will remain in the excitation mode. Okay, now we can directly connect this bulb to the alternator. Let's see. Yeah, so guys, as you saw that the system was working much better than it was working previously, and the capacitor excited alternators work really good. But the only problem is that you have to charge these capacitors first, and then only you can use it in the excitation mode as a battery. Also guys, before finishing off the video, I also wanted to check if this same setup is also going to work with this small capacitor, 15,000 microfarad at 25 volts, instead of this large capacitor bank, which is really difficult to find. Yeah, its capacitance is very high, so it can be used as a battery of course, but is the system going to work with this small capacitor bank? Let's find out. So guys, the first part is to charge the capacitor bank. This is the negative terminal. So this is the positive, blue is positive, blue and then white. Yeah, the capacitor bank should be charged now. Let's connect it to the alternator. Okay, so guys, this one is the positive, so blue will be connected to this wire. And after I have turned on this machine, then I will touch this wire to the negative and see if it enters the excitation mode. So let's turn it on. Okay, so it is at high speed now. Let's connect this terminal to the alternator. Go. Seems like it is working. The system has slowed down. Yeah, let's check if it is handling load or not. Oh yeah, it is working pretty good. Wow, great. And of course we can disconnect the capacitor after the alternator has entered the excitation mode. All we need is the excitation mode. Yeah, working really good. Okay, so guys, as you can see that the three-phase generator is ready to generate electricity, and as you can see when I'm rotating this magnetic drum, then voltage is being displayed on the multimeter. Now guys, I have connected only two wires from three-phase terminal because this meter measures only single phase AC and not a three-phase. So one of the wires, which is the yellow wire, is being left out. Now the power of this brushless DC motor when used as a generator is going to be around 600 watts. Yeah. So let's measure how much voltage I can generate by hand crank rotation. Okay, watch the multimeter screen. You can see that a simple hand crank rotation I am easily achieving around 20 volts AC. Let's go a bit further. Yeah, 36 volts. Let's try and go beyond 36. Yeah, 49 volts was the maximum that I could get. The non-rotating one. Okay, let's go. I generated around 65 volts with the rotating crank. Now let's connect some actual load to it. 12 volts car headlamp. I've connected only two terminals as I did before. Okay, go. Yeah, it was really difficult to rotate, but it can easily handle this much power. Okay, so guys, let's do some amps test. you can see that the maximum current discharge of a 12 volts 7Ah UPS battery can be as high as 350 amperes. The number of turns per pole for the armature winding of a starter motor are very less, because of which it requires around 14,400 RPM to produce just 12 volts DC. The second drawback is that at such a high RPM, the brushes will wear out very fast, thus making it impractical to be used as a generator.